So initially I was a little bit worried when I first showed up and I saw Brad's talk directly adjacent to mine, and I thought, how are these going to be connected? But actually, as I heard your talk, Brad, I think there's a lot more connection on a higher level than I initially had hoped, or thought, rather. So I'm going to talk about something that's mostly driven by the software, or let's call it process, and some of the different ways that we're thinking about how to model buildings and understand the performance of a building at a very, very early stage. So our main issue is really that there are two kind of ways of modeling, and I'm speaking about building energy modeling a building. And right now they're somewhat divergent, and one gives us the opportunity to kind of understand on a very basic level what the building's performance may be, and the other is a very detailed model. So there are compliance model, as most of you know, and there's the conceptual model. And the conceptual model is great for understanding on a whole some fundamental ideas, but it's not as detailed and doesn't get into systems. Actually, you know what? Let me just go back for a second. So the idea is not so much that we combine the two methods to come up with a third that is ideal, but more or less we grab the concepts that are important for the design and we find a way of combining them on a per project basis that makes sense. And so right now we really don't have the capability to do that. There are a number of things that exist that allow us to go down either road, but there's nothing that really kind of ties them together that we found. So this kind of brings into question or sets on the table the idea of computation, or what Autodesk is referring to as generative design. So using things like Dynamo and Grasshopper to explore building energy modeling. And what that does, essentially, I'm not quite sure what the landscape of the crowd is, how many of you are experts and know and use this thing already versus those who don't really know, but I'm going to give a general overview. So generative design or computation is essentially a new kind of parameter. And for those of you that work in BIM, you understand very well what a parameter is in the context of within BIM. But you can imagine a computational parameter as more of a concatenated element as opposed to an independent variable. So I like to always think about it in the way that I kind of talk to clients when we meet with clients and other professionals as well, when we're not working as an integrated team, is that I consider computation or generative design as the breaking down of the elements that define the building both conceptually and performance-wise as variables that help determine how the design cannot be automated but can be influenced by the connected nature of those variables. So if we kind of step back and we look at historically how buildings have been executed, we'll see that it's a very linear process for the most part, and this still kind of exists today in a lot of BIM environments, which is to say that we generate ideas that are our understanding of the design. We sketch those ideas on paper, we then digitize those ideas, and that's kind of where BIM steps in, right? It's a way of digitizing the analog. And we may rapid prototype some of these things, we may not, and then they eventually end up in construction. So that, of course, requires a lot of going back and forth, right? Because when you get to a certain stage in the process and you realize you need to reevaluate, you need to go all the way back to the beginning and start over again in some respects. Now, the reason that I have that little brain and little database symbol down there is because eventually at the end of the presentation, I'm going to make a bit of a right turn and talk about AI. What we're doing right now is we've kind of built our own AI and machine learning platform that harnesses, or harvests rather, all of the information that we're producing. So we still work on projects where we have linear processes like this. But with the idea of BIM, what it kind of adds is it turns that line into more of a circular process. So the principle being that all of the elements are more interconnected, coordination is easier, although what's ironic here is that coordination exists, but it still requires checking and updating and linking individual elements together in order to validate the information. So it's not really a real-time process, which, of course, the next stage of this, which the contractors mostly are kind of ahead of this, and what we're really investing our energy in is kind of, I like to sometimes refer to it as almost beyond BIM or BIM with another dimension. So some people refer to it as 4D construction. But the idea that everyone is simultaneously working within the same space on the same data, so you can never have someone complain, oh, I didn't get the file. So as an example, I'm just going to make a platform example here, is something like Dassault's 3D experience, where what we're trying to do is snap on elements and the concepts of what that are onto existing BIM to create a more aligned VDC solution, which is all of the elements that define the process of making a building become harnessed and kind of interconnected with one another so that you don't have these gaps of conflict through coordination. Now, just bring this back to building energy modeling for a minute, is that that's a massive piece of this puzzle, in that what happens is buildings have a tendency to kind of right now start in a phase where you heavily consider sustainability, and then you go through this whole process and nobody really checks it until compliance, and you realize that you're either out and made a mistake, or you've got to go back and pick up a whole set of points somewhere on the back end to try and meet your initial understanding. So the idea of VDC is that it brings it together. So I'm just showing a couple of projects in which, essentially to illustrate that kind of we've been down this road before. So we've done some relatively sophisticated buildings where we've done the compliance modeling, and kind of what we've learned through or from these buildings is that it's a hell of a lot of work to go cut a model off, do the compliance model, because you basically essentially need to rebuild everything to get that to work. And there's got to be a better process here whereby we can integrate building performance or energy modeling up front and be able to somehow componentize the elements that make the compliance model highly detailed by embedding those elements that make it worthy of city approval up front in the process. So what are the pieces of that puzzle that can help us do that? Now, I'm glad that 2030 came up, because that's something that we take extremely seriously. We have committed to 2030, and quite frankly, it's going to be a major challenge for us, because we have a lot of projects that are incapable of being neutral. So what that means is that a lot of our projects moving forward are going to have to be actually net positive to compensate for the projects that are going to come nowhere near that standard. So how do you design hospitals and essentially mixed use or multi-unit high-rise residential buildings? These are the sorts of conversations we're having with our clients right now, not halfway through and budgeting. This is something we're talking about throughout the entire process of design. And what we're trying to do is come up with solutions that do this right at the beginning. So what I'm going to do is I'm just going to show you how we're kind of employing it right now at the early stages of design, and then show you some of our compliance models following that. So the challenge for us, again, as I was saying before, is the idea there are functional limitations which are driven by tools and software for us, and then there's also the challenge of just getting our client to buy into this idea. So how do you convince your client that design will be just as good, just as innovative, performance will match, and it's not going to cost them a ton of money or very little extra on top of what they're already planning to spend? So what I want to reiterate is that the whole reason we're doing this is to make great buildings, not to be technically capable of doing things cool and different and innovative in terms of how software works, but to be innovative and forward-thinking in terms of what buildings mean to the public and how people engage public space. So what I've got here is a quick little diagram that shows a whole bunch of tools that some or all or many of you may be familiar with. I like to say that Rhino and Grasshopper are not really BIM, they're more generative, and you could argue Dynamo is maybe not BIM as well, it's something a little bit different. But we know that Revit is BIM, and we know that the path to IES is via Revit, which is the primarily accepted standard for building energy modeling. And then there's Building Energy Modeling Lite, which the most popular tool for that, which is open source, that exists, that a lot of people use as well for early stages of design and concept, is Ladybug, if you're a Grasshopper user or even a Dynamo user. So what's a little bit new, and Autodesk, to their credit, have kind of given us insight. And that's something that we're actually starting to work with now. And what's really important to us is not so much that we have something to use, but what is the validity of the metrics that are output from the platform. So we kind of use IES as the metric, the base standard, and we compare the output of the other elements to that standard to make sure that we're within the same ballpark. Now, of course, there's I don't know, is it going ahead here? Oh, here we go. So what we're trying to do, essentially, is erase the idea of barriers and pathways and connections that make us go down certain ways, and then to find a way to kind of harness the data and be able to interconnect all these elements without having to travel a certain path. So the idea is to basically create a data exchange environment that allows us to pass the information back and forth without us having to be constrained by the tool itself. And so, as was said before, the only way we've really figured out how to do that is to write our own software to mitigate this. Now, hopefully this plays. I'll talk about that in a second. So what you're seeing now is institutional building whereby we're analyzing the facade design, but also the solar radiation performance. So what you're seeing in pink is essentially a solid panel. What you see in yellow and cyan a little bit is our window units, so unitized units. So what this does is actually track the exterior performance of the building, and it's showing you down below. In this case, it's actually showing the cost metrics. But we can play with the design, as some of you may be familiar with, and at the same time, we're integrating the performance element into it to be able to see if we extend the exterior frames, what is our performance gain based on that extension. And so we can set limits for ourselves, we can evaluate that. These are all regionally based driven costs. So in this particular instance, they're Ontario costs. So what you're seeing is you're seeing quantities, which we can do with BIM, and costing in real time, but at a very early conceptual design phase. So we're not doing it post facto, we're doing it right at the beginning. This helps drive our design intent and our decisions, not after the fact. So here's an example of a building where we used generative design and building energy modeling from all different phases, created a whole bunch of custom applications, not only to study design, which was a major driving factor, but was also to drive performance. So intrinsically link performance in terms of lighting and energy and solar absorption to help guide the design strategy. So in this particular case, it's a double skin facade, and the panels are actually optimized by the software. And not only that, the depth within the system itself and the orientation of the panels and the angles of the mullions actually help dictate where light comes into the building as well. So through this process, we don't, again, back to the idea of being able to connect a whole bunch of different tools throughout the process, we're more interested in not what it is that specifically helps us get the job done, but how to actually deliver the design the way we want it. So printing various options, and this actually helps our clients understand. I think the biggest thing is that clients sometimes have a tough time understanding the virtual model. So we can show them a whole bunch of building energy model solutions that say, well, this one is better than that one, and they look at it and they're just like, yeah, that's, they look at the pink and they're yellow, yeah, that's cool, it's something my kid would color, but what does that mean to me, right? So for some reason, until you actually make the thing three-dimensional and real and put it in front of them, they have a hard time sometimes understanding what that means to design. So what this image is meant to illustrate is that we did about 33 different 3D prints at about a 3-inch cube type scale, just to show them what the building could look like based on different representations driven by the same performance values. And again, this comes back to that whole idea. We're studying different facade patterns to see which one of these makes the most sense for the, not just for the design, but for performance as well. So you see completely different patterns. As well, you see our lighting analysis. So lighting is also directly linked to performance. And so we're studying different envelope patterns and seeing what their effects are on the usability of the space and what that means. And this is the building that we're looking at happens to be a retrofit of an existing building. So what the client has decided to do is keep the existing core elements, so slabs and core, and basically rip off the face of the existing building and demolish a couple of adjacent buildings. So they're very mindful of the fact that they don't want to throw everything into a landfill, and so we help them through that process, try and figure out what makes the most sense for them to keep. So just going to step away actually from the energy modeling for a second here, because I think this was kind of interesting and I wanted to share this with this group, is that we're not just only looking at, and I suppose this maybe comes back to in terms of embodied carbon, but we're not only looking at optimizing, say, for energy, but we're also looking at optimizing for cost and construction. So what this illustration is meant to show is that we've tried to essentially design as many similar panels as possible while still keeping the design. So you'll see that the blue lines around the middle are essentially a transfer zone where we go from one element of the tower to the other, so they absorb. They're a little bit different because they absorb the transition based on the twisting of the skin, excuse me. And the corners essentially are all unique. What's interesting is that we brought in a third-party consultant to evaluate our findings to see if we were actually on target in terms of meeting our construction tolerances as well as our optimization. And we were within around 0.7% of a third party evaluating our optimized design. So we were really proud of that. So stepping kind of back into building energy modeling for a second here, I had mentioned trying to achieve 2030 on hospitals. So Aslan will be familiar with this screenshot, which is Autodesk Insight. So we are trying to evaluate right now, if you look at the EUI number returned in the top left corner, it's actually pretty spot on for a conventional type hospital at 320. And what we're doing right now is we're not so much relying upon this as our answer, but we're trying to essentially understand how accurate is the system. So if you're going to generalize a solution, what does that look like relative to a extremely detailed compliance model? And what we do is we track this against our expertise in previous hospitals we've done to say, okay, this is the hospital at a state, at a stage where we're using completely conventional systems. We're using essentially passive means of orientation, screens, exterior screens, all the standard stuff that you can do before starting to go into depth with more high performance, using solar, using active systems to reduce your footprint. So we know where we're starting. So now we can have the conversation with the client to say, look, if we build you a building that is standard by all means, this is where we'll be. But now we can go, let me just go back for a second, actually. But now we can go and do a variation on that model, integrate new systems, and tell them, but if you want to be forward-thinking, this is where we need to be, and these are the sorts of systems we need to use in order to get there. And again, this is at a conceptual stage of design. So we have a Revit model that's conceptually driven, ironically, by some Grasshopper scripts. So Revit being piloted by Grasshopper, which is kind of funny to some of the technologists because they think, well, that's not real stuff. So we have these conversations internally about that, but anyhow, that's another thing. So what I wanted to show here was, the conversation came up about designing buildings very early on, the commercial model, high-rise residential. And what I wanted to show was we built essentially a reporting tool or a client-facing forward tool where we've completely abstracted what a building is. So we've reduced it down to an extruded rectangle. And what we're showing here this is a baseline target designer. So what it says is, oh, I want to achieve LEED silver, LEED gold, LEED platinum, or I want to hit 2030. We haven't put living building into this yet, or passive house, but the idea here is that you pick your target and the form changes based on what your desired target is. What clients realize immediately is how much solid facade they need on their buildings, as opposed to what they're used to getting in that type of construction. So they realize right away, holy cow, like, I'm not going to have an ivory tower, right? If I want to go that route. Now, what's interesting is that we can tie that back to like a hypothetical EUI projection. We have cost metrics in here too. We can switch out systems, right? So none of that's in this interface, but it's kind of behind the scenes. So right away, this is a really, really powerful thing to do with a client in like 15 minutes, and they realize, yeah, you know what? You know right away if they're committed or whether they're just saying they're committed to this agenda. Because a lot of people will actually see this and say, well, that's great, thanks very much. I had no idea that this was possible. And then other people are just like, yeah, no. Because they really want the glass. Now, which can be done, but takes way more work. So moving forward, what's really, this is actually the ball or globe from Science World. A client came to us, and I actually just only saw this the other day, and I thought it was a great example actually given this talk. And a client came to us the other day, said, you know what do we do? We're really considering, we need to reclad. What if we reclad the entire outside of this thing in solar panels? What are we going to get? What's our yield going to be? What's our performance going to look like? And we thought, well, it is a sphere, so really your incidental absorption rate is only going to be as the sun tracks. So we're kind of interested, what's that going to look like too? So what we thought was, it kind of sparked our imagination. We thought, okay, well, we've got these triangles. What's our optimal dispersion or format of panel on that triangle? So we studied a few more than the ones I'm showing. I'm just showing two for an example here. But then we also looked at the incidental radiation absorption. So what we did was we set it up and animated over, obviously not a 24-hour period, but sunset to sundown, or sunrise to sunset. And then we drew a whole bunch of diagrams to show what our yield was, and then we looked at our numbers and we thought, it doesn't make a lot of sense. But we knew right away looking at it that obviously, and I mean, some of this is intuitive and just comes to mind right away, is that you need to move the skin out beyond the structure in order to actually even begin to talk about valid optimization rates. So there was that whole conversation, and the client thought, maybe it's not worth it. So although it didn't turn out to actually be a project or anything like that, it was a really interesting exercise for us to work with somebody to understand what the capacity might be for, what's interesting in the first place is that even came to us and we're thinking about that. So we were really impressed by that. Now this is an example of a competition we did internally for San Francisco State University. And essentially the reason I'm showing this is because it is a building whose design is 100% linked to performance in every way. So this was a completely carbon neutral building or concept for building, and it was driven by everything from solar to ground source heat pumps to the human related factors to how people perceive space, and all of that was driven generatively to dictate the form of the building and optimize exposure, orientation, and spatial relationships within the building. And I'm not just talking about the exterior landscaping, I'm talking about the programming within the building itself. So a lot of this goes just beyond numbers and math and mechanics. It actually comes back to how people live within space and how they feel about a building, right? Which, again, comes back to making architecture and not just for the sake of incorporating technology. Now, this is the complete antithesis to everything I've just shown you. thinking about a compliance model, which is a highly driven, fundamental metric-driven exercise, rather. And some of you may be very familiar. The city is definitely familiar with IES. What's great about it, it's a really powerful tool, but what's not great about it is we essentially have to remodel, and what you're looking at here is a wireframe of a building, remodel the entire building in another platform after we've already done all that work in BIM, which is a bit of a pain in the arse. So there's got to be a better way to do this, although what's important about these slides is not so much the fact that it is a bit of a painful process, but the amount of detail that we get in this. This is a diagram that basically is just showing how the mechanical systems, they're color-coded, each mechanical system, what element of the building it's serving. So it gives us an understanding of what spatial element is being serviced by what piece of equipment. And this is just a heating loop, so this is showing us the heating for the building. Sorry, I'm realizing I'm yellow now, so I've got to speed up a little bit. And this is the cooling map, right? So what's important to kind of, and this is essentially the AHU schematic. So what's important to take away from all of those slides is not so much that it's detailed beyond comprehension, but the fact that there is a level of detail that we can incorporate earlier on in the earlier stages. So the way that we've gotten around that is we were able to kind of work with IES to come to an agreement, which involved lawyers and passing back confidential information with each other, to develop our own intermediary Python scripting that will allow us to work between and control unique elements of IES earlier on in Revit and Dynamo and in Grasshopper, without having to rely on their systems. So it gives us that ability to leverage the compliance strengths earlier on in the conceptual phase of the process. And we're in the early stages of this, and it's a significant investment in time and energy, but we think that it's worth it because it's going to give us a level of detail that we've never seen before at this stage of the process. And this is an example of a building that is driven by that process. I can't say who the client is, but I'm allowed to show the picture. It's in this city. So parallel connected, bear with me, this is a lot to digest. So essentially what the slide is showing is that the way that we commonly work right now, as I've been saying, is kind of the top gray bar, which is to say that mechanical consultant, or sometimes our own mechanical team, works in parallel to architecture, but they have a bit of a stall initially. They kind of, because we are always changing stuff on the engineers constantly as architects, that SDDD phase is painful for them. And so traditionally what's happened is they kind of wait for us to get to a point where things have become solidified. We have client approvals and they kind of get down to business. They get their elbows in there and they start moving around. And then at the other end, they come out and they produce a compliance model once our contract docs model has been kind of solidified. So what I've just been talking about this whole time is that our capacity to code and create custom software allows us to actually intertwine that process throughout and not have to rely on that model. It means that the mechanical engineers can get involved in concept, they can actually help drive concept, and our buildings are better for it. That's essentially the point of this slide. Now, very lastly, I'll go through this because I have like 2 minutes and 15 seconds. What the heck does AI have to do with any of this? A lot, actually. As you can imagine, a lot of this is information. Anytime you generate a lot of data, if you can access that data and harness it and use it to make better decisions, that's why artificial intelligence is very important, and that's what's going to help us do as a profession. So we've built essentially our own system of a bunch of elements that are all together. They have their own kind of like plugins, and they hook into everything we use, from finance to HR to building energy modeling to BIM to computation, generative design. And basically the point of all of this is that all of these little bits that we've designed as part of its kind of like its own operating system sort of thing, extract that information and do different things with it. And how this relates back to BIM is, I'm sure a lot of you are very aware that Revit has exceptionally detailed log files. And we're leveraging those log files and analyzing them with our AI to be able to understand a number of things, and not just to like poke at people and say, why'd you make that mistake? It cost us $1,000 or $10,000 or whatever. But to say, what did we do wrong here? What can we do better? And so this is what our AI database looks like. For those of you who've ever used Dynamo or Grasshopper, you'll think that's something I can get with. And what this is showing is the connections between elements. You'll see Jeff there, the little blue guy, is connected to a whole lot of projects. And what I wanted to just basically show you with the last couple seconds is this thing happening in real time. So some of this may be a little high level. What this is basically just showing is our web interface that is showing that data is being recalled and read in real time. And what you're seeing right now are new connections that are being made and harvested. So as each one of those bubbles explodes and expands, it's actually learning new information and new connections between all of the other elements in between. So it just keeps growing and growing and growing and growing and growing. And as it does that, we can filter it, we can call things. Now this is the back-end development environment, but you'll see what the front end looks like in a minute. It's pretty bad, actually. But what you'll see is that a whole bunch of connections are correlated. So we have a whole bunch of auto-classifiers that essentially make sense of the information, right? So what do you do with it? Once you bring it in, you've got to do something with it for it to be useful. So in this example, what I'm showing essentially is the fact that there's a news article. This is not specifically BEM or anything like that, but there's a news article that's relevant to a certain group of people. And that news article is learning who it's connected to within the larger organization. And as it does that, what you'll see is it's actually saying, you know, this is who it's relevant to, and this is the front-end interface, and you'll see that it actually says it's green space, and it belongs to the green team, and here is the article. And you can launch the article, and it brings you to that. So what it does is it allows people to actually use plain language now to interact with the information within our organization. So the last thing I want to show you, I'm a little bit over, I'll be done in a minute, is bot interaction. And I think a lot of people will find this really interesting. Now this is Slack, but we use MS Teams as well. So pay attention to what's happening here. Someone is basically asking a robot that it wants to create a site review report. And the robot is asking him, what's the name of the project, what's the project number, and he's answering, and it actually does all of that information for him. And I want to explain why this is relevant. Now, this is a removed example, but it's relevant because everything I've just talked about right now is driven by parameters, right? Design is driven by parameters, metrics, goals. If we can interact with design on a plain language level, we can set up our buildings from the beginning to ask them questions like, say, what does the performance look like if I want to achieve LEED Silver? And the bot will go and run the model and say, this is what the building looks like if you want LEED Silver. So everything we're doing is laying the groundwork for a Google-type system that allows you to interact with design with your voice or by asking questions. So we think that the future of design, part of it is intrinsically linked to what we've developed here. And lastly, just want to give you guys a bit of binary here to say thanks.
Thank you, Mark. Thank you very much. Any questions from the audience for Mark? Quick questions before we go to our break? I've got a quick one.
Sure.
Data mining and harvesting, obviously, of your projects. We're putting a lot of data and information into our models, and you're starting to extract it in ways that are quite unique, that are helping you progress design further. How is that resulting in impacting your design, not the design process, but the actual design?
Yeah, that's a tough question. Well, is it fair to say that design is highly subjective? So how it would impact the design can be directly influenced by the rules you set up to allow it to affect the design. So there's
Right.
still a heavy hand over the control of what the concept behind it is. It's just the way you can interact with it is a little bit different. So you'll see, I've been at a lot of conferences where there's a lot of talk about AI designing buildings, right? Which in my mind seems kind of cool, but is also a little bit scary because it kind of removes the license behind like why we do this to begin with, which is that each of us has different ideas about what the reaction to that design is. Even as a team, we have a different idea than another team. That's why Dialogue competes against Perkins and Will, and the client chooses what design they like better because subjectively they like one over the other.
Yeah.
If robots just design everything, does that mean they all become soulless and the same? I don't really have the answer to that question, but I would say that we work within the context of what the rules are based on how we want it to look.
Right, so I'm interpreting that, and I might get you to move some
Oh, yeah,
closer to the
sorry.
mic, as you're using the information that you're mining from current projects, past projects, to help, I don't want to say educate the design, but maybe shorten that design timeline because you've got a whole bunch of existing parameters and information that's guiding you to a design process.
That's absolutely part of it, but when you think about it, historically, we've, within, I would say, the last 5 years, we've made a serious, committed, and concerted effort to making significantly higher performing and better buildings. And let's just talk about it in
Right.
the context of sustainability. You rely on data from like 50 years ago. It's not really relevant because nobody cared, right? So, and there's still projects where it doesn't come up. So there are elements that are important, elements that are not. Where mining is one aspect of it, it's just recalling and bringing that information in. The AI comes into play where it says what's relevant, what's not.
Right, so you're filtering that information.
Right,
to
and
what's
it
relevant.
only presents and makes relevant what is relevant.
Right.
to the
Very
process.
Interesting.
Yeah.
Excellent. Thank you very much. Any quick questions quickly for Mark?
That was a very interesting presentation. You know, I have a colleague who does energy performance modeling, as I said, in Ontario,
Right.
for new buildings. And he complains that he always gets the model after it's already been designed, and all
Yep.
he can do is move windows around and so on.
Right.
I mean, could you conceive of Revit or Tekla or you know, Bentley BIM or whatever, having IES integrated into it so that every time you placed a beam somewhere, you would immediately see what the energy performance of that whatever you had at that point?
That absolutely is what we are aiming to achieve with our relationship with IES. Is they've only recently and not even publicly exposed certain elements of their product that allow you to control it in many different ways. And so that's what we're trying to do, is we're trying to close the loop in the cycle so that, like, as you say, it becomes an earlier conversation at a much more detailed level and requires a lot less effort to do. And so it's part of the front end and not the back end. Yeah.
Right on. Good. Thank you very much, Mark.
Thank you.
Appreciate your